When it seems like the world is descending into irrationality and chaos, why not retreat into math, where the answers are pretty much agreed upon and people don't get into debates over them? I'm going to now continue my series from of old, in Calculus 2, and we're in integral calculus, and we're in partial fractions. Partial fractions is it's not miraculous, it's a wonderful way to solve certain kinds of rational problems. Integral, you're trying to integrate something with this over this. And I already done one video where the numerator is larger than the denominator. That's easy, you just divide it out. Good old long fashion. But what happens when the numerator is not bigger than the denominator? Well, here's the first in that series. What if the denominator breaks down into linear factors? What does that mean? It means you can break it down into, say, x's that are all to the first power. So here's an example. All right, so this is one of the problems in, it's chapter 6 in one version of James Stewart, and it's chapter 8 in the old one. But, okay, so this is, at first you might say, well, Ken, this denominator is not first power, but we can factor it into it. So use your factoring skills. X squared plus 2x minus 15, what do you get? Well, an x times an x, 3 times a 5 maybe, and 3 and 5 are differ by 2. So I think, using your old algebra skills, you can see that that one factors out into linear factors. See, this is first power, this is first power. All right, so now we're cooking. Now, here's where the magic comes in. If you're like me, you first look at this and you say, you can't do that. You're not allowed to do that. Well, A is a variable we're going to solve for, and B is a variable we're going to solve for. So there is a certain A and there is a certain B that will make this true. We just have to find out what it is. And to do that, what we're going to do is we're going to multiply this whole thing by the denominator. We're going to just multiply the whole thing through, and here's how it ends up. So when we multiply this side by the denominator, bloop, it disappears. Tops and bottoms cancel out. And so we're left with x minus 9. When we multiply this denominator times this, the x plus 5 cancels out, and we're left with x minus 3. And when we multiply this by the b, the x minus 3 cancels out, and we're left with x minus 5. So again, we're trying to figure out what this a and b are. So we're actually making good progress here. So here's what we ended up with on the previous slide. Let's go ahead and do a little shifting around. Let's gather ye rosebuds while ye may. Let's gather the pieces together. The x's, let's gather in front of the x's, and then the constants will gather with the constants. And here's what we end up. So we've got a plus b x and 3a minus 5b. Now, why did we do that? Because you can see that there's a 1 in front of this x. And so a plus b equals 1. And then minus 9, this constant here is going to equal 9. Isn't that magical? It's magical. It's wonderful. And so now we've got two linear equations, or we've got two equations with two variables. Two equations with two variables. We're going to be able to solve for a and b, basically. So next slide. Let's solve for a and b, shall we? So here's what we ended up with. So this is easy. A equals 1 minus b, or you could do b equals 1 minus a, and then we're going to substitute into the next one for either a or b. So, for example, if a is b minus 1, 1 minus b, so substitute a into this one. Minus 5b equals 9. We've just we've made this equal a, and we've substituted in for a. Now we have to solve. So 3 minus 3b, equals 9. Or again, this is fairly easy. Negative 8b equals, etc. And get everything on the right side. Now we're going to divide. I wish it was a nice number. It's not, but it's not too bad of a number. Negative 6/8, reduce it. Negative 3/4. We've solved for b. Now let's solve for a. A equals b 1 minus b, so a equals 1 minus b. 1 plus 3/4 is 7/4. So we've now solved. We know what a and b is. Now we can go back to this equation. Remember this equation? This is what we had just a second ago. We're going to substitute in for a. We're going to substitute in for b. There you have it. And now let's do a little simplification. Let's bring the 4s all on down. So 7/4, got it on down. 3/4, got it on down, and I changed the sign. Now, when we go back to the original, basically the integral of this, that's what we started off with, right? What's the integral of x minus 9 over x plus 5 times x minus 3? That was our problem. We're going to take the integral of this, and we can pull these apart, right? Because the integral of this is the integral of this minus the integral of this. The integral of this minus the integral of this. And this is fairly simple to solve for because the integral of 1 over something is the natural log of that thing times the derivative. And the derivative of the x is going to be 1. So that it disappears. So basically what we end up with is, there it is, the integral of that is going to be 7/4 the natural log of x plus 5 minus 3/4 the natural log of x minus 3. In other words, it's going to be that. And you could stop there, I suppose. I don't know what your teacher wants you to do, but you might remember that natural log minus natural log is the same as the natural log of this over this. And then the multiplied could be a power. All of that is to say is this, if you want to simplify it, you can say 1/4, because both these are 1/4, the natural log of x plus 5 to the 7th over x minus 3 to the 3rd plus a constant. And there we've done it. It looked hard. We didn't know what we were going to do, but by using partial fractions, we were able to solve this puppy. So practice makes perfect, but there you have it.